Hi everyone, welcome to another video, and in this video we're gonna solve another question called rotting oranges. So as the question suggests, you are given an m cross n grid where each cell can have one of three values. So what are those values? A 0 representing an empty cell, 1 representing a fresh orange, and 2 representing a rotten orange. So every minute any fresh orange that is 4 directionally adjacent to the rotten orange become rotants. So we have to find the minimum number of minutes that must elapse until no cell has a fresh orange. If this is impossible, return -1. So basically we have a grid, and in that particular grid a 2 represents a rotten orange. So every 1 minute anything that is 1 and adjacent to that 2, right, it will become rotten, or we have to convert that into 2, and we have to keep the count. So how we can do that? Let's discuss that on the whiteboard. So let's take this example here. We have a 2 cross 2 matrix, right? 3 cross 3. Let's take it 3 cross 3, and it has values like 2 1 1 and 1 1 0 and 0 1 1. So here in this particular case the 2 is the rotten orange, so this is rotten orange, and 1 is a fresh orange, and 0 is empty box. So it says that in 1 minute, for example minute 1, any fresh orange that is adjacent to 2 will become rotten. So this will become 2, and this will become at minute 1. And second time, when at minute 2, adjacent to these 2s, like this one and this one, will become rotten. And at minute 3, adjacent to this 2 is equal to this one, this will become 2. At minute 4, this one become 2. So all the fresh oranges in this particular grid will take 4 minutes to become rotten. So we have to return 4. And also, if after processing this everything, if we still left orange, then we have to return that -1, that we cannot make the box rotten. So how are we going to solve that? For example, consider this again. Let's go to the initial case, right? So first we have to go through the grid, and we have to find out what those cells are, those that we have to process. Here this one, right? So 0 1 0 2 0 3 sorry 0 0 0 1 and 0 2. I'm just writing the I and j index here. 1 0 1 1 1 2 2 0 2 1 2 2. Okay, so first I have to iterate through the grid, and I will create a queue and put that index where I find the rotten orange, that is 0 0. And once I iterate through all the cells, I will find that only one cell is there, right? So I will make a queue, and then I will process the queue. The first one I'm gonna pop it up, so I will get the node 0 0, and then I will process it. So from here, is there any fresh orange adjacent to this node? Yes, this is the one and this is the one. So I will make those two oranges 2 and push these 2 nodes to our queue. So our queue will now become 1 0 and 0 1. Right? And second iteration again, also simultaneously I will keep track of the count, right? Count now become 1. Then again next time I will process these 2 nodes, that is this one and this one. Then I'll convert this to 2 and this to 2, and I will push these 2 indexes to the grid. Our count became 2. And the third time again I will pop whatever there in the queue and process those. At that time I will get only 1, that is I will make that 2, and I will push that to 1, and at the count become 3, when count become 4, I will process this one and will push the 22, right? I'll put this one and push 22, and then I will pop it up and process it, and by that time our count it become 4. So basically what I'm trying to say is that we have to make a queue, and we have to make a queue, and simultaneously we have to process those nodes that we set in the queue, and mark the fresh oranges in 2 and keep counting how many minutes passed. At the end, when our queue is empty, then again we have to see if there is any one left in the whole grid. If there is still someone left, then it is impossible to make the whole grid into roten, so we have to return -1. But core logic is that we have to maintain a queue and keep processing the nodes. And then there are some edge cases. If there is only roten orange and there is no one, then we have to return 0, as per you see, as per the example, right? 0, and if there is one left after processing, then we have to return -1. If every cell becomes all the fresh oranges become roten, then we have to return the minutes. So now let's implement that using JavaScript. Please don't. Yeah. So here now, first let's implement a queue. So class queue equals you're gonna constructor, we're gonna put like this dot queue equals to a blank array, and then we have to put a method called add so that we can add values. So this dot queue dot push val, then we have to add a method called pop so that we can pop values from our queue, and we'll return this dot queue dot shift, and then last one we're gonna implement a method called size, and this size method will return us the length of the queue. Simple. So if you don't want to implement like this, you can create an array and keep inside the function and use that as a queue. I'm just creating that so that it will be very intuitive to write our code, and it will be easy to understand. So first thing first, we have to find the x limit and y limit, or I limit or j limit. If you create two pointer I and j, what is the max limit? I mean the length. Again, I'm writing this first because so that we don't have to write those dot length -1 multiple time. So let I limit j limit equals to grid dot length -1, and the second one will become like grid of 0, then dot length -1. Simple. Now we have to write our for loop to find out if there is any roten orange there in the grid. We're gonna find out that. So let's create a queue. Let queue equals to new queue, and then for I, then array will be our x limit, sorry, I limit I plus plus, and then we have another for loop, that is j, and then this will be like j limit. Simple. Now we're gonna find if like there is any roten orange present in this grid. If we find one, then we have to like push that to our queue. So if grid of I and j equals to 2, then we have to like q dot add, what do you have, we're gonna keep track of count. So our first count will be 0, right? Then we have to keep track of I and j, so I and j. And then also let's keep track of 1, so that if there is no 1 present in this particular grid, we just have to return, we don't have to do any calculation, right? So let's create a variable, let fresh, right? So is fresh present false, right? So we have to check is any fresh orange presence. So if grid of I and j is to 1 is fresh present equals to true. Okay, so after that we have to see if there is no is fresh present, then we just have to return 0, right? No, if there is fresh, if queue is empty, we did not find any roten orange, and there is fresh is present, then it's impossible to make it right, so we have to return -1. So let's do that. If q dot size equals to 0 and is fresh present, right, then we have to return -1, because it's impossible to make it, right, impossible to make it roten if there is no roten orange presence but fresh presence. Else, if not is fresh present, if there is no 1 presence and only 2 presence, then we can return 0. Simple. Now we have to process the queue, right? So while q dot size greater than 0, let node equals to, we're gonna pop, right, this dot sorry, q dot pop. So we're gonna get this node, then we have to, let's create another variable, let count equals to 0. Okay, so we will be incrementing this count, so we'll be keep track of that. So here when you pop a node, we have to calculate our count, math.max count plus node.count. Then we have to process our node. Process node. So now let's create this method. Now function process node. So in the node we will have three variables. So let's destructure it. Like we're gonna get count, we're gonna get I, we're gonna get j equals to node. Now from every ij we have to go into 4 direction. So let's do that. If I not equals to 0, I not equals to 0, yeah, simple. So we're gonna go, let's make it more intuitive. We're gonna go in this direction. If I minus I minus 1 greater than 0, greater than equals to 0, then we can go to I minus 1. So and grid of I minus 1 and j equals to 1 means it is fresh. If it is fresh, then we have to mark the grid of I minus 1 j equals to 2. Then we have to push the same node to q, right? So q dot add our count plus 1, and then we have to do I equal to I minus j, I equal to I minus j, I minus 1, and we're gonna pass j. Perfect. So we covered I minus 1. Now we have to cover the next one. So let's copy this 4 times. So I minus 1, then we have to do I plus 1. If I plus 1 smaller than equals to I limit, then we have to do I plus 1 and j equals to 1. Then we have to mark I plus 1, j equal to 2, and here we have to do I plus 1 and j. Perfect. Now we have to keep I constant and do our j operation. So if j minus 1 is greater than 0, so keep I constant, then j minus 1 equals to 1. Then we have to make I constant, j minus 1 equals to 2. Then yeah, same here, j minus 1. Perfect. Same thing here. Now we're gonna do j plus 1, j plus 1. Now smaller than equals to j limit, and keep I constant. Now make it j plus 1 equals to 1. Then here the same, you're gonna give j plus 1 equals to 2. Here the same, keep the I constant, and we have to make j equals to j plus 1. So we covered all 4 directions. Let's verify it. I minus 1, perfect, and then I plus 1, perfect. Now I plus 1, j minus 1, j minus 1, j minus 1, j plus 1, j plus 1, j plus 1. Perfect. So by end of this one, right, our count should have the value. But again, after a while, right, after the while loop, when all the nodes processed, after that if any one present, it means it's impossible to make everything rotate. So again we have to write a for loop to check if there is any one any fresh orange presence. So let's check, like for I, then we have to do like 1 second, we don't have to do I limit length here, see, perfect. We have to I limit I plus plus. Same way we're gonna do like for j, here we have to do like j limit j plus plus. Now if read of I, read of j equals to 1, return -1. Perfect. This will take care of, at the end of processing everything, if still there is any roten present, it will take care of that. At the end, just return, just to return your count. So this should solve our problem. Let's run some test cases here. What happened? Oh, sorry, spelling mistake. Whew, where is the grid? Grid, everything perfect. Now let's run it again. Okay. -1. So it is returning -1 instead of 4. And if you see, our logic is perfect, but it's not going to this process. This, the while loop, is never works. So it's not going to process, so it's returning -1 from here. So I find out the issue, and it's nothing to do with this code. The problem is here. I'm not returning this value, and it's not getting the size, and oof, now it should work. Perfect. The -1 condition is not working now. We see before 2 1 1. So at the end there will be this orange. It's not adjacent to any orange, so it will stay there. So our logic to this one, I j limit I plus plus, we have to make it equals to. Same goes to here, we have to make it equals to, because we already subtracting -1. Always I messed that up. Let's do now. Yeah, so it worked. So let's now try this posting in our lit code. Perfect, everything has passed. Now let's submit. Perfect. It's not that efficient. Maybe there's some kind of efficient solution is there, we have to see. But that's that. We'll see. Thank you for watching.